Barend. Thank you very much. Still waiting for Tom. Okay. Yeah, Tom, you want to say? You want to start?
Yeah. At this point, I'm looking at my screen also for the Q&A session. So I invite the participants to chat on the Q&A session and to come up with questions. I think the speaker could not be more clearer in the need for fair data. So one of the things that have come out from the panelists is a discussion on if we want to be fair, we should be not only findable and accessible, but it should also be interoperable. How are we going to do this, and why are data that are being collected by the WHO not yet interoperable, which addresses many of the issues that Barend Mons just mentioned? So maybe Barend could comment on this.
Yes, thank you very much for also giving me the opportunity to speak, but well, record and to answer questions now. Let me say one thing in vote on one of the GoFarians. The first thing we did with funding from Zonneweg is take the WHO CRF, the case report form, and make it fair. And that means that we keep the form as it is, but we have 4 independent implementations that if you type in that form a ambiguous term, or you type it in your own language or whatever, which would not render it fair, and you save the form, it will produce RDF, which is one of the fair formats. So now it doesn't really matter whether you fill the form in Chinese or in Dutch or in English or whatever. All the concepts that you mentioned, virus, fever, you know, loss of taste, they become the same unified, globally unique, persistent, resolvable identifier for the machine. So the machine understands the form. So that was the first step. But of course, there is still a big difference between having this technically solved and people actually deciding to use the form. So if doctors insist to write with their fountain pen on paper, we cannot help them anymore, okay? So it's the burden to do this is largely social. Technically, we know how to do distributed AI, distributed deep learning. We know how to map between different ontologies and do quas and conceptual modeling. The thing that stops all this is political and cultural. And don't get me going on the reward system for science, the journal impact factor, and supplementary data, which are all horrible things that stop open science.
The first questions are coming here in, Matthias. Can I launch my first question?
Matthias is muted.
I'm muted. Okay, thank you for telling me. Yeah, so there is actually a hand up by Carsten Baldorf. Let me actually just ask him to unmute and that he can ask himself. Carsten?
Yes, I also want to be seen. Sorry, doesn't matter. I was wondering, I mean, you showed this overview about drugs that are interacting with proteins related to COVID-19. And you took the data from Wikipedia, Wikidata, which is, it's a valid data source, but did you try? And if so, did you have problems getting data from big pharma companies? Because in principle, they probably have even better and more compounds tested. I mean, they have gigantic libraries of compounds that they screen against everything.
Yeah. But what we did to show the use of the model, first of all, I wanted to do the drug separately. But we saw what happened when Trump said hydroxychloroquine, it was sold out everywhere. And people with lupus and malaria probably couldn't use it anymore. So we decided not yet in the publication that we have, this was a preprint, to take any particular drug, but just show the proof of concept that you can take any drug. In this case, we took the list from Wikidata that they collect, and they know they're already promoted in some way, shape or form to work for COVID. And we showed that we could test them all within 5 minutes. Okay. So one other example, and I'm not sure we are allowed in a recorded session to even mention Big Pharma, but you know, everybody knows that Roche has the monoclonal tocilizumab, which is a strong IL-6 inhibitor. It's normally used for rheumatoid arthritis. So in several hospitals, they test this already existing drug to treat COVID patients. But Roche is in one of the sub-projects in Wodan called TWOC, the Trusted World of Corona. And they are in there with actual funding to evaluate the use of their monoclonal in which phase of the disease, because they know that if you give this monoclonal, which is expensive, they cannot scale it up too easily. If you give it at the very late stage of the disease, when the cytokine storm is already raging and the downstream effects are there, it may make no sense at all to inhibit the IL-6, but it does earlier in the disease. So we are actively working with the pharmaceutical industry, but I cannot, of course, show their internal slides. So if we place this in open science context, FAIR is not the same as open, as we know. FAIR data can be highly restricted. We say everything you do in our hotel, so in the Dutch Tech Center for Life Sciences, we now have an hotel where we can play with this model. If you want to keep things secret, you buy a license, you do it at home. If you want to do it openly, you come to the hotel, but you know that everything we find, even if it doesn't suit your purpose, will be published immediately. And with reference to a good friend of mine, Jan Veltrop, he liked this idea of open science. He said, you either pay attention, your knowledge, or you pay money. So if people want to keep things closed, they pay. If they allow it to be open, we have a hotel and it's free at the point of use.
Okay. Thank you. Can I have another one or rather not?
Maybe we switch to one of the attendees.
Okay.
Yeah. There was a question, very basic question, Søren Auer. He mentioned, how can we make it easier for researchers to produce FAIR data? Very valid question,
yeah.
And not an easy answer, but please.
Well, there's a number of issues. If we talk about entering data, of course, we are working very hard. I gave the example of doctors. They are much worse than scientists. Well, no, both are very bad, and I'm one of them myself, a biologist. So, you know, we make 15 different names for the same gene. We make a big mess. We know that all. So the first thing we know is we need to make this extremely easy indeed for doctors, for scientists. So we have to connect electronic lab notebooks, the normal forms that people use in the hospital to fill. And we have to make it so that these forms will generate FAIR data as much as possible automatically. That's for the future. And of course, if we make our data FAIR-born, FAIR at the source, the problem will go down with 80% data munging. When my minister asked me, how much will this cost to make everything FAIR in hospitals? I said, well, 10% of your savings. We all spend 80% of our time data munging before we can launch our AI, because the machine has no clue what you mean if you say PSA, prostate-specific antigen. It has 189 different meanings in Medline alone. So it is a duty of scientists, but we have to make it as simple as possible, integrate it in normal workflows, and legacy data can be made FAIR in so-called BYODs, bring your own data, and we can help people to make old data FAIR. And one more thing maybe, which is even more important technique, we have to stop judging people on their stupid journal impact factor. Because if we keep doing that as deans, they will wait with sharing their data until they have their Nature paper. We should reward people for making their data FAIR, sharing them, and build an open science paper. So I will tell you that for this paper on COVID, we published version 1, people can comment, they can become co-author, the paper grows, the model grows, it's all versioned. That's open science. We should quit this stupid idea that we wait 4 months to publish a Nature paper in this case, it costs lives, people. We cannot do it. And this is much more important than the technology, is the culture change.
Very important message. There is another Q&A from James Warren, one of our speakers also, and he says, is it also possible to detect the bad data to avoid sloppy signs, to find malicious mischief or worse? So the question is, how do you build trust in the FAIR model?
Yeah, very important question. I've even been invited to Brussels by Timmermans to see whether we could detect fake news. But of course, you have a knowledge model of all established knowledge. The company we use, Euretos, has integrated 275 databases. Of course, if there is a new assertion coming into that system and it causes a lot of tension in the model, there is an alert. But this could be a lie or a scientific breakthrough, because scientific breakthroughs do not fit in the common knowledge as well. Of course, they should not be completely out there, but tension in the graph is a sign something is happening. There's even entire, theories, chaos theory that we imply here for percolation points. And you see that we discover knowledge very logically at the edge of chaos and order. We turn perceived chaos into order, and then we call it knowledge, okay? Now, I always say when people talk about fair and quality and bad data, even more important than quality is provenance. Because is self-reporting data in COVID apps bad data? Quality is in the eye of the beholder. With what do you want to use it for? But I want to be able to tell my machine, exclude any self-reporting. So I need for every assertion and association that comes from self-reporting, like loss of taste and smell, and it's only coming from self-reporting, I want to be able to filter it out. So in the FAIR environment, provenance, the exact source of the data, which machine was used to generate this sequence, or this, image of the molecule or whatever, I need to know so I can filter on it. Quality is a very dangerous aspect, but I keep saying that when I was still working on malaria, we had this complete fake movement that said that some Colombian scientist, Patarroyo, had the vaccine. We all knew it was wrong, but it took 10 years for WHO to recognize, and there were political issues, developing countries, Name our own famous Dutch psychologist, I won't mention his name. I'm convinced that if all the data that were underlying those papers that were totally made up were fair, the machine would have at least detected the tension in the graph. This is not fitting with general knowledge. That doesn't make it necessarily wrong. It could be a major Nobel Prize winning breakthrough, but at least it will focus our attention on the tensions in the graph, which could either be fake news or bad data or scientific breakthroughs. Machine is not able to distinguish. That's why we still need people. Good news.
Very good.